Welcome to the ninth lecture of Digital Electronics subject. In this lecture, we are dealing with gray code. So, coming to the topics of this lecture, we will be dealing with an introduction to gray code. Second one, gray code to binary, and from there to decimal conversion. Then third one, binary to gray code. This is our decimal number, convert to binary, then back to gray code. So these three are the topics in the scope of this lecture. So coming to what is done by gray code. Gray code is basically a numeric code. Numeric code. It uses binary number system as reference. Now, in gray code, two successive numbers differs only by a single bit. Okay. So these three are the definitions of gray code. Gray code is a numeric code which uses binary number system as reference. And if two successive numbers are there, it differs only by a single bit. Okay. The advantages of gray code. First one. Suppose if you are using a hardware and you are using some analog to digital converter. Okay. So to feed it to the processing circuit, digital processing circuit, a corresponding binary pattern will be generated. Okay. Now this binary pattern may contain errors. Okay. Whereas if you are using coding in this case, if you are using coding instead of binary pattern, that means especially using gray code, that error, the formation of errors can be avoided. Okay. That is the first advantage. Second advantage is it is not a position weighted code. It's not a position weighted code. But it involves bit change. That means for successive numbers there is only a difference of 1 bit. Okay. Now another speciality of gray code is that suppose you have a series of gray codes, then the first n by 2 gray codes will be a reflection of last n by 2 gray codes. Okay. Now that this part will prove in this lecture. This is an important feature of a gray code. This part will prove by the last of this lecture. Now, before going into gray code, how to generate gray code? We need to know about one basic thing. Okay, the basic thing which we need to know is exclusive OR gate or XOR gate, or exclusive OR gate, or exclusive OR binary calculation. Okay. Here, the steps or the 4 key points or the 4 rules in this XOR R. If you are having two bits 0 and 1, 0, 1. If 0 and 1 is XORed, then the result is 1. Whereas if 1 and 0 is also XORed, you will get 1. Whereas if you are XORing the same bits 0 XOR 0, that becomes 0. 1 XOR 1, that is also 0. Okay. So these are the golden rules which you need to remember while generating a gray code. That is 0 XOR 1 is 1, 1 XOR 0 is 1, 0 XOR 0 is 0, and 1 XOR 1 is 0. Okay, these are the golden rules or key points which you need to remember while generating a gray code. So I'll show an example how to generate gray code. So obtain the gray code of 9 to the base 10. That means here I am giving a decimal number. So first you form the binary of 9. How will you form the binary of 9? 9 by 2 is 4, remainder is 1. Divided by 2 is 2, remainder is 0. Divided by 2, 1, remainder is 0. Divided by 2, 0, and remainder is 1. Right from bottom to the top. Therefore 9 to the base 10 you can write it as 1, 0, 0, 1 to the base 2. Okay, this is just binary representation. Now, how to generate gray code from this binary representation? So binary representation I am writing as 1, 0, 0, 1. 1 you write directly. Next one, 1 XOR 0. 1 XOR 0 is 1. 0 XOR 0. 0 XOR 0 is 0. Next one is 0 XOR 1. 0 XOR 1 is 1. That is the gray code for 9 to the base 10 is, you can read this from left to right. That is 1, 1, 0, 1. Okay. That is how you are generating the gray code of a binary number. Okay, so here I have converted from decimal to binary and from binary to gray code. Okay, this is a conversion from decimal to binary, and here I have converted from binary to gray code. Okay, so I am proceeding. Next question, obtain the gray code corresponding to the binary number corresponding to 1, 1, 0, 1, 1. Okay, so this is a binary number. So you can write it as 1, 1, 0, 1, 1. So 1 you can write directly. 1 XOR 1 is 0. 1 XOR 0 is 1. 0 XOR 1 is 1. 1 XOR 1 is 0. Therefore the corresponding gray code. So you can write it as 1, 1, 0, 1, 1 to the base 2 is same as 1. That is gray code. The gray code is 1, 0, 1, 1, 0. That is the gray code. Hope you have understood the conversion from decimal to binary as well as decimal to binary as well as binary to gray code. Now I need to convert a gray code will be given. I need to convert a gray code to binary format. How is it possible? I will show with an example. Convert the gray code 1101 to binary. Now see, it is specified that 1101 is gray code. So how will you convert it into binary? So 1101. So what you can do is 1, 1. Then this 1 is XORed with this 1. What is 1 XOR 1? 1 XOR 1 is 0. Next one, 0 XOR 0. That is, sorry, 1 XOR 1 is 0 XOR 0 is 0. Again, 0 XOR 1. 0 XOR 1 is 1. Therefore, we can say, therefore, if gray code is 1101, then binary code is, corresponding binary code is 1001 to the base 2. Okay. So now I have shown if a gray code is given, how to convert it into a binary code. Okay. That means that second part can be generalized as, in general, if a gray code is given, like gn minus 1, gn minus 2, etc. g0, and let the corresponding binary code be bn minus 1, bn minus 2, etc. b0. Then bn is equal to gn. Bn is equal to gn. Then bn minus 1. Bn is equal to gn. Then bn minus 1 is equal to bn XOR gn minus 1. Yeah. Then bn minus 2. Bn minus 2 is equal to bn minus 1 XOR gn minus 2, etc. Here you will get g1 b1. You will get b0 is equal to b1 XOR g0. So whether I have done, oh, there is a mistake here. There is a mistake what I have done here. That is here. Here in this generalization part I have done a mistake. Sorry for that. See, if binary code is bn minus 1, bn minus 2, etc. b0, and gray code is gn minus 1, gn minus 2, etc. g0, then we can write gn is equal to bn. Gn is equal to bn, and gn minus 1 is bn XOR bn minus 1, and gn minus 2 is bn minus 1 XOR bn minus 2, etc. g0 is b1 XOR b0. This is the corresponding. Okay. Sorry for the mistake which I have conducted just before. So this is how you are converting a gray code to binary. Okay. This is a generalized form of conversion of gray code to binary code. Okay. Now coming into a broader picture of this gray code. Okay. So let me have the decimal numbers and the corresponding binary numbers. Okay. So 0, 1, 2, 3. Okay. So I am having a 3-bit. I am going for only 2-bit. So 0 is 0, 0. 1 is 0, 1. 2 is 1, 0. 3 is 1, 1. So I need to get the gray code of this. Okay. So how do you find gray code of 0? Decimal is 0. How do you find gray code? Binary is 0, 0. So this is 0. 0 XOR 0. That is 0. So what we can write? The corresponding gray code is also 0, 0. If it is 0, 1, how do you convert? 0, 1. 0 is kept here directly. 0 XOR 1 is 1. 0 XOR 1 is 1. So it is 0, 1. Gray code is 0, 1. Now next one. Next is 1, 0. 1, 0. 1 is kept there. 1 XOR 0 is 1. That is 1, 1. Last one. For 3, binary code is 1, 1. 1, 1. So it is 1 is kept directly. 1 XOR 1. 1 XOR 1 is 0. That is 1, 0. Now, if I am drawing a line here, we can see that in the first column, this is the if I am considering this as a mirror, what you can see, the last column or the zeroth base, this is the last column. This is the mirror image of this one. Okay, this part is the mirror image of this part. Okay, so that is how gray code is becoming a reflecting code. reflecting code. So here only the first bit. This is the second bit. Only first bit is getting reflected. So 1 is reflected 1, 0 is reflected here. Okay, that is why it is known as reflecting code. I will show one more example. Same. I am going for 3-bit combinations. So decimal I am writing up to 7. 0, 1, 2, 3, 4, 5, 6 and 7. The corresponding decimal I can write it as corresponding binary. Corresponding binary I can write it as 0, 0, 0, 0, 0, 1. 2 is 0, 1, 0. 3 is 0, 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. 7 is 1, 1, 1. So I need to produce the corresponding gray code. Okay. So 0 is kept as it is. 0 is 0. Again 0 is 0. Here 0 is kept as it is. 0, 1, 1. Yeah. 0 is kept as it is. Then 0 is 0. 0 1 is 1. Then next one, 0 is kept as it is. 0 XOR 1 is 1. Then 1 XOR 0 is 1. Then 0 is kept as it is. 0 XOR 1. 0 XOR 1 is 1. Then 1 XOR 1 is 0. Okay. Now 1 double 0. 1 is kept as it is. 1 XOR 0. 1 XOR 0 is 1. 0 XOR 0 is 0. Now 1 is kept as it is. 1 XOR 0. 1 XOR 0 is 1. And 0 XOR 1 is 1. Here 1 is first bit. 1 is kept as it is. Then 1 XOR 1 is 0. Then 1 XOR 0 is 1. Here 1 is kept as it is. 1 XOR 1 is 0. 1 XOR 1 is 0. Again 1 XOR 1 is 0. So if you are taking a line here, you can see that except the first column, you can see this part. So here I am taking this part. Okay, this part is exact reflection of the down part. That is exact reflection of this part. Okay. So here what we can see is that here these are reflections. Therefore we can say that your gray code is a reflecting code. It is a reflecting code. Okay. Hope you have understood the concept of resetting code. Okay, that means here 0 0 1 1. That is exactly reflected as 1 1 0 0. Then 0 1 1 0. That is again reflected as 0 1 1 0. That is how you are getting the reflections. Hope you understood what is gray code, how to form gray code using XOR logic. So one more technique I will explain while forming a gray code. Okay. That is a very simple technique. So that technique is known as shifted binary technique. Shifted binary technique. For formation of gray code. So here, for example, I need to obtain the gray code of 1001. Okay, need to obtain the gray code of 1001. So what to do is you shift it 1001 like this. Then add these two. So you will get 1 plus 0, 1, 0 plus 0, 0 plus 1, 1, 1, and neglect this part. So you will get 1101. That means here 1101 is the gray code. Is the gray code of 1001. Okay. So now I have mentioned two methods of forming gray code. One is XOR method, and the second method is using this shifted binary technique. Second method is shifted binary technique. These two techniques are for forming gray code. Now, in this lecture, I also have explained if a gray code is given, how to convert it into binary. So it is 1 0 or it is 1 1 0 1. I need to convert it back to binary. So 1 is taken as same. 1 XOR 1. 1 XOR 1 is 0. Then 0 XOR 0 is 0. 0 XOR 1 is 1. So you will get so this one is the corresponding binary code. So hope you have understood the concept of gray code, and I think you have understood how it is mirrored. Okay, how that mirroring happens also. Okay, so that proves that gray code is a, see here, that one, first n by 2 gray codes will be a reflection of last n by 2 gray codes. That is also proved in this lecture. Okay, so thank you, and in the next lecture we will be starting with gates. Okay, so we have completed almost all the codes. Now, sorry, not gates. We have now next one is we need to go with error detecting methods, and after error detecting codes, we will go with logic gates. Okay, that floating point and fixed point arithmetic, that also I am keeping it by side. Okay, okay. Now, so the next lecture will have a introduction to this some codes, and we will start with basic gates, and or and not are the basic gates. Thank you.